A couple of vocabulary words with regards to gases and how they move and get through places. Effusion and diffusion. They sound very similar, and indeed they are very similar processes. Effusion is the slow, quote slow, whatever that means, escape of a gas through a small opening in a container or partition. Diffusion is the natural random motion of, uh, of particles in a sample to fill an available space. So let's see, effusion is through a small hole, and diffusion is just a spread of a gaseous sample into occupy an entirely available volume. Both these processes actually they occur as reciprocal. The rate of these processes occur as a function of the inverse square root of the molar mass of the gas. It's called Graham's law of effusion. So here's the gas over here in the left-hand side of the container. A small hole, doesn't even have to be a hole. Actually, helium, for example, a small gas like helium can escape through the pores in just about any balloon. Can't escape from a metal container, but plastic and mylar balloons certainly can't hold the helium forever. So through the small hole, the gas eventually makes it through, just because of natural random collisions. I suppose you could say the bigger the hole, the faster they effuse. But in any case, as a function of the inverse square root of the mass. So hydrogen. Oh yeah, here's a graph of the speed. Does it make sense that hydrogen? We already talked about this, right, with the root mean square speed video. The smaller the gas, the faster on the average, and also the faster the root mean square speed. Uranium hexafluoride, very heavy, very slow moving, would move slowly and effuse and diffuse slowly. Let's compare hydrogen gas to oxygen gas. Hydrogen weighs 2.02 grams per mole. That's 1 for each hydrogen. Oxygen O2 weighs 16 plus 16 is 32 grams per mole. And that comes out to the square root of 32 or the square root of 2, and looks like about 4 times faster. Hard to predict that number 4 without actually doing a little calculation. Hydrogen escapes about 4 times faster. It would effuse from a balloon 4 times faster than oxygen gas would. Now, at least that's the theory. Same story for diffusion, but we'll leave that for that's a whole other topic, can of worms. But so let's compare HCl to HE. Doesn't matter which one. Well, actually, let's put since these are all numbers larger than 1, let's put the molar mass that's larger on the top. So let's call gas 2 HCl, and let's call gas 1 HE. So if helium weighs 4 grams per mole, and HCl weighs 35.5 plus 1 is 36.5 grams per mole, that's about 36 over about 4, and that has a kind of a, oh, I didn't write it down here, what the heck. Alright, well, fine. So let me say it again. HCl weighs about 36 grams per mole. He weighs about 4 grams per mole. Square root of 36 is 6. Square root of 4 is 2. 6 over 2 is 3. So let's go this one. Did I do that mental math correctly? 4 over 2. No, I did it wrong. No, I did it right. Square root of 36-ish is 6-ish. Square root of 4 is 2. So 6 over 2 is 3. Yeah, 3 times faster. Got it. Interesting. In other words, the rate of effusion or diffusion, but effusion of a gas through a small opening, is proportional to the inverse square root of the molar mass. And if I were to increase the mass of a gas, or compare one gas that's 10 times more massive than the other, wouldn't that mean, let's see, what's 1 over the square root of 10? Seriously? Yeah, right, 1 over the square root of 10. So that's got to be about 3.6 times faster? No, slower. As the molar mass of a gas increases, the rate of effusion decreases by a factor of 3.16. Interesting and messy. Hey, these last 2 slides, I'm kind of embarrassed to say that I'm showing them to you because they're wrong. If you take a more advanced course and study diffusion, it actually takes quite a bit of time. This is often shown in general chemistry books, but it's wrong, so I'll say it again. It's wrong, but it's interesting. If I take some HCl in a cotton ball and put over here, and take some NH3 aqueous, this is HCl aqueous, this is NH3 aqueous on a cotton ball, and you plug one end of this open glass tube with the NH3 cotton ball and the other end of the open tube with the HCl in a fume hood, so you don't have to smell this stuff because they both stink pretty bad. Which is going to diffuse through the space faster? Well, in theory, since this weighs 36 grams per mole and this weighs 17 grams per mole, the lighter one diffuses faster and travels further, and the heavier one diffuses slower, and by the time they meet up, you see a cool little smoke ring. This is a picture of it right here. This cool wispy smoke ring. Well, that's all well and good, but honestly, if you were just and only talking about diffusion, to go even a few centimeters takes quite a bit of time. So actually more time than we want to stand around and watch. So what's happening here really is convection currents because of differences in heating, and for one reason or another that also gives you a very similar answer. But again, this is an incorrect slide, but a funny question which you might see, so I'm going to show you the question even though, as I said, it's wrong, because this is not just diffusion, it's more like convection and motion due to other air currents. If I put HCl in one corner and NH3 in one corner and H2S in one corner and methyl, I think it's called methyl mercaptan, or it's a CH3SH molecule. This one smells like hydrochloric acid, this one smells like ammonia, this one smells like rotten eggs, this one smells like, I shouldn't say it to be politically correct, it just smells bad. Which of these four molecules, if released at the same time in equidistant corners to the room, if I was in the middle, which one would I smell first? Well, if indeed it was diffusion, but it would take a long time and no convection, I probably would smell the lightest one first, don't you reckon? Sulfur's pretty heavy, it weighs 32 grams per mole. I think it's this ammonia because it's the lightest. Oh wait, is that right? Yeah, right. This one weighs 17 grams per mole, so it would be B, is the one you'd notice via diffusion or effusion first. Thanks guys, see you in class. Have a swell day.